Let's start with setting up the scanner. First, plug in the scanner, take the data cable, and plug the two ends of the cable into your scanner, and then plug the USB side into the computer. Now, take your power adapter, yours might look a little different, and plug it into the wall, then into the port on the data cable. After a few seconds, you should see lights on the scanner, indicating that the device is powered. Now, use the included USB drive to install the scanning program. When you first launch the program, it might prompt you to update. Always keep the software up to date. If it's your first time using the scanner, you will have to create an account and sign in. Now let's start calibration. Calibration should be done whenever you move your workstation, or whenever you drop or knock your scanner over, as well as if you notice any strange behavior or reduced performance with the scanner. When calibrating, you can either do a standard calibration or a quick calibration. For most situations, a quick calibration should be fine unless it fails. Since this is our first time using the scanner, we will do the standard calibration. Stand the calibration board on the guide. Align it like so. Make sure it's the right side up, as indicated by these marks on the board. To calibrate, position the scanner as shown on screen and advance through the steps. Move the scanner back and forth as needed to light up each bar on the right side of the screen. Do that for each step and make sure to angle the scanner appropriately for each step. Once that is done, we will then calibrate the lasers. This is simply done by turning the board over to the white side and laying it flat. Only one step is needed. Just hold the scanner facing down at the board and move the scanner up and down to light up all the squares. This step might require a slow and steady hand. Lastly is the white balance calibration. Keeping the board how it is, we will do a single step very similar to the laser calibration step. We just need to bring it to the correct distance, somewhere in the middle. No further movement is needed. Now we have finished and we're ready for scanning. Let's start by choosing laser scan mode. Laser scan will give us maximum resolution and help us scan shiny surfaces as well as darker surfaces. However, we'll need to use markers on our object. Let's select our resolution. The scanner needs to see at least 4 markers at a time to maintain tracking. Keep that in mind when you place your markers. If you put too little, you can always place more mid-scan. Let's choose our surface mode to match our object, and then let's get scanning. Aim the scanner at the subject, and then press the play button on the scanner to enter preview mode. This will give you an opportunity to see if your starting position is good, and if the geometry of the object will be captured. You can adjust the brightness with the left and right face buttons. The up and down buttons will zoom the camera in and out on screen. A good rule of thumb for if you need to adjust the brightness is, if you can't see the laser lines on the subject, you need to increase the brightness. However, if it's too bright, the scan quality will suffer. Press the play button again to begin scanning. Once you're done, or if you need to adjust the object to get another angle, you can press the play button again to pause the scan. Now let's talk about data editing. There are many tools we can use to clean up our data. By holding shift and dragging with the lasso tool and the other selection tools, we can select data in the shape of our choosing. Holding Alt while doing this will also deselect selected data. Connected to main will select all data physically connected to your selection. You can invert this to select a lot of garbage data like floating bits, and then we can delete. The clipping plane tool can be used to delete all data under a flat surface. It's great for tables. You can select a portion of the table and create a plane. The plane can be moved, deleted, or you can keep it and it will filter out data, making sure nothing under the plane is captured. Let's generate point clouds to get a better look at our data and how it might look when it becomes a mesh. We can keep scanning past this point. If we are happy, we can also go ahead and mesh. But before we do that, we're going to take a look at project groups. Project groups allow us to scan our object in multiple parts. This can be used for larger objects or some clever techniques and workarounds. Things like digital assembly, which is a more advanced technique that we'll get into in a separate video. Project groups can also be aligned together for meshing later. To make a new group, right-click in this area and make a new group. Select it and scan as you like. After you generate point clouds in this group, you can then click here to align. Alignment can be done in a few different modes, automatically by geometric features or markers, or manually by selecting similar points, or by selecting matching markers. Selection is done by holding Shift and clicking, but most of the time, automatic mode works just fine. We could mesh now, but we're going to get into that later. Instead, let's check out Rapid Scan mode. Rapid Scan is great for scans where we don't want to use markers. Also, Rapid Scan can utilize texture capturing, allowing your scans to create full color textures while we scan geometry. Rapid Scan, as the name implies, is also very quick. Rapid Scans have a lot more settings for their projects. We have tracking type, resolution, and texture. Let's look at tracking. We have feature tracking, which uses geometry to capture. Doesn't require markers. It should be noted that feature tracking requires your subject to have rich geometric features. Feature tracking also has trouble with repeating patterns and symmetrical objects. That is why I usually go with hybrid tracking, so I can use features for most of the object and use markers where it needs some help. Texture tracking similarly requires the texture to have rich distinguishable areas, and also requires that you have the texture turned on. Now let's begin scanning the same way we did with laser. We'll tweak our brightness so it only shows a little bit of red. Let's finish up our scan like we did before. We'll clean up this data, and then we'll generate point clouds. That looks good to me, so we'll go ahead and press this button to mesh our point clouds. We have a lot of settings to play around with when it comes to meshing. Most of them are self-explanatory. Watertight will automatically seal any areas missing from the scan. After meshing, we can go back and play with more settings if we don't like it. If not, we can confirm. There's also a great deal of post-processing options. We can optimize the data, change the file size by simplifying the object. There's hole filling, both automatic and manual too. We can modify the texture and add smoothing. These are great to play around with to tune your mesh exactly to your liking. After that, the mesh can be exported directly to your program of choice or saved in a file. Measurement tools can also be used to capture the measurements of your mesh. Like the rest of the program, the controls for choosing points in areas of the object for measurement is to hold Shift plus clicking, or hold Shift plus dragging. And that's about it. Everything you need to know to use your Einscan HX. Thanks for watching.